Now see this question. Here the arrangement of 12 cells, each of internal resistance 1.5 ohm, to give maximum current in external resistance of 2 ohm is n cells in series connected m times in parallel. Okay, and here we have to find m and n. See, it says that the 12 cells are arranged in series and parallel to give the maximum current through this 2 ohm. For this, n cells are arranged in series. It means when n cells are connected in series, then total resistance is equals to nr. Now when such nr rows connected m times in parallel, then total resistance, equivalent resistance is equals to nr by m, because when m number of equal resistances are connected in parallel, then total resistance or equivalent resistance is equals to the value of individual resistance, that is nr divided by m. So equivalent resistance is nr by m. Now for maximum power transfer, this nr by m, that is equivalent resistance of this battery combination, must be equals to this 2 ohm. Only in that case power transfer is maximum or current transfer is maximum. So from this R is equals to 1.5 ohm. So we get N upon M is equals to 2 by 1.5, that is equals to 4 by 3. It means resistances are connected in this combination where N is equals to 4 and M is equals to 3. It means four batteries, 4 cells are connected in series, and this combination is repeated m times, that is equals to 3 in parallel, like this. Again this 4, again this 4. So here internal resistance of each cell is 1.5 volt. So total resistance of each branch is 6 ohm. This is also 6 ohm, that is 1.5 into 4, that is also 6 ohm. And total resistance equivalent is equals to 6 by m, that is total number of these rows. So 6 by m is equals to 6 by 3, that is equals to 2 ohm. So in that case this 2 ohm will become equals to this external resistance connected to it, that is also 2 ohm. So answer is n number of cells in series and m is equals to 3. Now see this question that has been asked in ES 1999. This question says that 5 cells are connected in series in a row and 4 such rows are connected in parallel to feed a current to feed current to a resistive load of 1.25 ohm. Each cell has EMF 1.5 volt with internal resistance of 0.2 ohm. The current through load will be. So we have to find the current through load. Here the question says that 5 cells are connected in series. It means total resistance of these 5 cells connected in series will be equals to R is equals to 1.5 into 5, sorry, total this internal resistance is 0.2 ohm. So 0.2 ohm into 5, that is equals to 1 ohm. Now total EMF when bed cells are connected in series, then total EMF will be, that is EMF of each cell is 1.5 volt. So we get 1.5 into 5, that is equals to 7.5 volt. Now this resistance is this EMF. Now 4 such rows are connected in parallel. So when we connect 4 such rows are in parallel, then EMF E is remain same, that is equals to 7.5 volt, because EMF in parallel is same. But what is resistance? That is equals to, when 4 such rows are connected in parallel, then resistance will, total equivalent resistance will become equals to 1 by 4, that is equals to 0.25 ohm. So we can represent this whole combination of cells as a voltage source of 7.5 volt in series with 0.25 ohm resistance. Now this combination supplies current to a resistive load of 1.25 ohm. This is 1.25 ohm. Now we have to find current through this 1.25 ohm. So what is current? I is simply equals to V by R, that is 7.5 by 0.25 plus 1.25, that is equals to 7.5 by 1.5, that is equals to 5 ampere. So I is equals to 5 ampere is the answer. Now see this question that has been asked in ES 1992. A 24 volt battery of internal resistance, that is equals to 4 ohm, connected to a variable resistance R. The rate of heat dissipation in resistor is maximum when current by battery is I. So here it is a battery of 24 volt and the internal resistance of battery is 4 ohm and it is connected to a variable resistance. Now rate of heat dissipation in resistor is maximum when current through battery is I. When heat dissipation is maximum, when there is maximum power transfer from this voltage source to this variable resistance, and when power transfer is maximum, when this resistance R is equals to internal resistance 4 ohm. So this R is equals to, when this R is equals to 4 ohm, then power transfer from 24 volt to this resistance R is current is maximum. And suppose this is current I when power transfer is maximum. So from this we can find I is equals to 24 V upon R. So that is internal resistance 4 ohm plus R is 4 ohm, because for maximum power transfer this internal resistance R is equals to 4 ohm. So we get 3 ampere. Now it says that when current drawn from battery will be I by 2. It means when current drawn from battery is equals to I by 2, it means current drawn is 1.5 ampere, because I is 3 ampere. Then in that case value of resistance R is, it means we have to find the value of this resistance R in this case. So when current I is equals to I by 2, in that case we can write equation as 24 by, this internal resistance will remain same but this resistance is variable. Now the resistance will be different when current is different. So suppose at present current is R, so that is equals to 1.5. So from this 24 is equals to 1.5 into 4 plus 1.5 R. So that is equals to 18 by 1.5 is equals to R. So we get R is equals to 12 ohm. So here answer is 12 ohm.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.